Activity 3.3, linear, constant, and exponential functions. Gather all of the graphs that you identified as functions. These are the graphs from Lesson 2. Take a moment to read this slide. Number 1, analyze each graph from left to right. Sort all graphs into one of the four groups listed: increasing function, decreasing function, constant function, a combination of increasing, decreasing, and constant. Please note that when you read a graph, you read it like you would read a word or a sentence from left to right. The increasing functions that you should have listed are graph F and graph I. They are going up. Start on the left and they go up. The decreasing functions are graph G, graph L, and graph M. They go down. The constant functions that go straight is graph R. The functions that remain, they're going up, down, straight, a combination of all. Graph A, graph B, graph C, graph E, H, J, N, P, Q, and S. Each function shown represents one of the graphs in the increasing function, decreasing function, or constant function categories. We're going to use graphing technology. If you have a graphing calculator, now would be the time to grab it. If you're not sure how to use a graphing calculator, feel free to YouTube some videos on how to use it. To determine the shape of its graph, then match the function to its corresponding graph by writing the function directly on the graph that it represents. For this video, I'm going to show you how to graph this using Desmos. Let's take this one right here. F of x equals y. Remember, f of x is the same thing as stating y. It's just in functional notation. Go to desmos.com and you'll get a way to graph these to get a visual of what they're going to look like. Here we're going to type in x, and it graphs a linear function. When you go back to your textbook, this graph should be graph F. Let's look at the next one, where you have 1/2 to the x power. I'm going to put 1/2 in parentheses. One half to the x power gives us an exponential function, a decreasing exponential function. If you notice, it starts out here and it's going down. This is decreasing. If we're going to graph the next one, the next one is 1/2 again in parentheses. Raised to the x power minus 5. So you see on this one, it's the same exponential function, it's just shifted down 5 units. You can continue to graph these on Desmos to get a visual of what your graphs are going to look like. Here's another exponential. Here's a linear function. So again, that's Desmos.com. Make sure you take your graphs and you label them. The first one, like we said, should be graph F. This one should be graph M. Then we have graph G, graph R, graph I, and graph L. They should match up. Consider the 6 graphs and functions that are increasing functions, decreasing functions, or constant functions. Sort the graphs into 2 groups and record the function letter in the table. So what we're going to do is we're going to break them up into 2 groups. Think to yourself how you could break them up. I'm going to break them up and put graph F, L, and R together. In group 2, I'm going to do graph G, I, and M. Think about why I grouped those together. What do you notice? In this first group, these are all my linear constant graphs. In this group, it is all my exponential graphs. Let's talk about linear functions. Linear means a straight line. To have a straight line, it's going to look like y equals mx plus b, similar to what they have over here. It is your slope-intercept form. Notice your x is to the first value. When your x is to the first power, it is a linear function. Here we have exponential functions. Anytime that you have a variable for an exponent, it's going to be exponentially increasing or exponentially decreasing. So look for that x as your exponent. You could have any number, but as long as you have that x as your exponent, it is exponential. Go back to your table in question 3 and identify which group represents linear constant functions and which group represents exponential. So we've already identified those. Group 1 are your linear. Group 2 is your exponential. If f of x equals ax plus b represents a linear function, describe a and b values that produce a constant function. So a constant function would mean a straight horizontal line. If you take f of x equals ax plus b, and if you use 0 for a, and we're going to create any number for b, let's say 4. Well, 0 times x cancels each other out. So you would just have f of x equals 4. So what you would have is a graph if this is your y-axis and this is your x-axis, it would cross right there at y equals 4. .4, let's talk about quadratic and absolute value functions. Take a moment to read this slide. This slide is referring to absolute minimum and absolute maximum, whether you're talking about quadratic or absolute value functions. A quadratic is a U-shaped parabola. It could be going up, or that U could be facing down. The lowest point is your absolute minimum. Your highest point is your absolute maximum. Same is true for absolute value. Absolute value are V-shaped graphs. The lowest point is your minimum. If your V is going down, your highest point is called your maximum. Sort the graphs from the combination of increasing, decreasing, and constant category in the previous activity into one of the 3 groups listed. Those that have an absolute minimum, those that have an absolute maximum, and those that have no absolute minimum or maximum value. Take a moment to sort your graphs. The absolute minimum graphs are graphs C, J, Q, and S. The graphs that have an absolute maximum are graphs B, E, H, and N. The graphs that have no absolute minimum or absolute maximum are graphs A and P. Number 2, each function represents one of the graphs within the absolute maximum or absolute minimum value. Use graphing technology to determine the shape of its graph. Then match the function to its corresponding graph by writing the function directly on the graph that it represents. So let's go back to Desmos and graph some of these functions so that you can get a visual. You could also use your graphing calculator. The first one we want to graph is x raised to the 2nd power plus 8x plus 12. This graph is a quadratic graph. Notice the x squared that we put in. Whenever time you put in an x squared, you are going to have a quadratic function. Let's continue to graph. Let's graph another one. Let's use absolute value. Let's do absolute value of x minus 3 minus 2. So there is our V-shaped graph, shifted over and shifted down. Absolute value function. And let's look at one more. You can play around this on Desmos. This is a free app. Let's say we have the negative absolute value of x. Notice that absolute value is going down. That V is pointing down. So here, this point is going to be your absolute maximum. It's the highest point. So for x squared plus 8 plus 12, that should match up with graph Q. Write this function down on your graph. The absolute value of x minus 3 minus 2 I believe there's a typo right here. I think that should be a minus 3 and a plus 2. That should be graph S. X squared should be graph J. The absolute value of x should be graph C. The negative absolute value of x should be H. Negative 3x squared plus 4 should be E. Negative 1/2 x squared plus 2x is B. 2 times the or is that negative 2? Negative 2 times the absolute value of x plus 2 plus 4 should be graph N. Apologize for the typos. Number 3, consider the graphs of the functions that have an absolute minimum or an absolute maximum. Sort the graphs into 2 groups based on the equations represent the functions. All right, so try to sort them into 2 groups and see what you come up with. For group 1, I'm going to have group B, E, J, and Q, those graphs. And then I'm going to put graphs C, H, N, S together. What do you notice that they have in common? Group 1 are my quadratics. They are my U-shaped graphs. Group 2 are my absolute value. They are my V-shaped graphs. So let's sum up quadratics and absolute value. If I'm going to have a quadratic, I am going to have my variable raised to the second power. Anything raised to the second power is going to give me a U-shaped graph. Anything with absolute value is going to give me a V-shaped graph. All of these are functions. Remember that a function is where the domain does not repeat. Go back to your table in question 3 and identify which group represents quadratic and which group represents linear absolute value functions. And we've already done that. Group 1 are your quadratics. And group 2 are your absolute value. Piecewise. Let's see if we can graph piecewise on our Desmos app. Piecewise look confusing. However, they're really not. These are just two functions pieced together. Take f of x equals -2 if x is less than 0. F of x equals 1/2 x minus 2 if x is greater than or equal to 0. So we're going to take a piece of one graph and a piece of the other and put them together. Over here, we have 3 pieces that we're going to put together. So here we are in Desmos. I'm going to graph -2. Well, I can't see how to graph -2, so I'll just show that one by hand. -2 is going to be a straight line. That looks very curvy. Going through -2. So remember the conditions for -2. All your x values have to be less than 0. So what we're going to do is we're going to erase the part that is not less than 0. I can't seem to do that. So we are not going to look at this part of the line. We're only going to look at the left-hand side. And for the other piecewise function, let's see if we can graph it. It'll be 1/2 to the x power -2 and so there we have our pieces together. And this one, for the blue line, all your x values are greater than or equal to 0. Greater than or equal to 0. Okay, so let's see if we can piece this together. For the pink line, you have your function f of x equals -2 when x values are less than 0. So I am going to try to get rid of the pink line on the right-hand side. And for the blue function, it is 1/2 x minus 2. Oh, I put it as exponential. Okay, so let me change that. Okay, so the pink line is f of x equals -2, x is less than 0. The blue line represents 1/2 x minus 2, and the x values are greater than or equal to 0. So we would get rid of this piece right there. And this would be a piecewise function. We took a piece of one function and a piece of the other function, and we made this function. So for the first piecewise function, this should form graph A. So label graph A, the piecewise function. This is going to be graph P, 3 piecewise function. You have just sorted the remaining functions into one more function family. The family of linear piecewise functions include functions that have equations either for different parts or pieces of the domain. You have now sorted each of the graphs and equations representing functions into 5 function families: linear, exponential, quadratic, linear absolute value, and linear piecewise. Glue your sorted graph functions into the appropriate function family graphic organizer located at the end of this lesson. Write a description of the graphical behavior for each function family. For example, we've talked about linear functions. We've talked about quadratic functions. We've talked about exponential functions. We've talked about absolute value functions. And we've talked about piecewise functions. Remember that linear functions form a straight line, and you're going to have x to the first value. Quadratic functions form a parabola or a U-shaped graph, and that's going to be x to the second power. Exponential increases exponentially or decreases exponentially, and you're going to have a variable for an exponent. Absolute value is a V-shaped graph, and you're going to have absolute value bars. Piecewise functions is going to be 2 pieces of a function pieced together. There, you're looking for something like this with conditions. You've done a lot of work up to this point. You've been introduced to linear, exponential, quadratic, linear absolute value, and linear piecewise functions. Don't worry, you don't need to know everything there is to know about these functions families right now. As you progress through this course, you will learn more about each function family. Please email me if you have any questions. Hold on to your graphic organizers. They will be a great resource moving forward.